Good evening. We're going to finish up 12.1 today and continue talking about gas laws. Gas pressure, pressure of any kind, is defined as a force per unit area. Gas particles exert pressure when they collide with the walls of their container. So remember, gas is going to take up whatever space you put it into, and it's constantly moving. So when it collides with the walls of whatever it's in, it's going to exert pressure. The particles in the Earth's atmosphere exert pressure in all directions, and this is called air pressure. There is less air pressure at high altitudes because there are fewer particles present, since the force of gravity is less. So here in Quito, we obviously have less air pressure pushing down on us. We also have less air to breathe, which is why sometimes walking uphill or running for long periods of time is different here at 9,000 feet than it would be at sea level. It's also why water boils at a lower temperature and sooner here, because we have less air pressure pushing down on the water, and it's able to boil faster and at a lower temperature. Torricelli invented the barometer, and barometers, I'm sure all of you are familiar with these, are used to measure atmospheric air pressure. So you'll hear meteorologists discuss about atmospheric air pressure. What it is basically the pressure exerted on a mercury column that's in a vacuum, and that pressure that pushes down is what we call the atmospheric pressure. A manometer measures gas pressures in the same way, but this is done in a closed container. So here we have a vacuum on either side, and it's closed here. And we have a gas on this side, and equal levels of usually mercury on either side here. When gas is let out and is allowed to go into the vacuum, however much pressure it gives allows for the mercury here to move. And the difference in the levels here determines what the gas pressure is. The significant unit of force is the Newton. There are several, the SI unit, so the main one we use is the Newton. However, there are quite a few ways of measuring force. 1 Pascal, so a Pascal is another way, and a Pascal is equal to the force of 1 Newton per square meter, or N, capital N for Newton, per meter squared. 1 atmosphere, this is another big way that we measure gas pressures, is equal to 760 millimeters of mercury, or 101 kilopascals. This is a chart that's in your book. I'm not going to ask you to memorize it, but I do want you to become very familiar with it. So I want you to pause the video here and read through. We've talked about kilopascals and atmospheres and millimeters of mercury. There's also a torr. There's pounds per square inch, which you would see when on the side of your tire of your car. It'll tell you how many pounds per square inch, or PSI, your tires should be at, and that just tells you how much air to put in them. There's also a bar. So go ahead and pause, read over these, and see how many equivalents of each there are. All right, Dalton's law of partial pressure. This states that the total pressure of a mixture of gases is equal to the sum of the pressures of all the gases of the mixture. So it's very simple. A total pressure is equal to the sum of all the pressures of the gases. So basically a total pressure is A plus B plus C all added up. The partial pressure, so this is a little bit different. The partial pressure of a gas depends on the number of moles that we're talking about, the size of the container, so is it in a really big container, or is it in a smaller container and more condensed, and then therefore the particles are hitting the sides more often, and temperature. Temperature plays a big role in gas. The warmer it is, the more it's going to move around. However, it is independent of the type of gas. So when we're talking about gases, they all tend to react, they all tend to have similar pressures. We just worry about the moles, the size, and the temperature. So here is Dalton's law of total pressure. And again, it's very simple. the total pressure is equal to adding up all the different pressures that you have. So here in this example, we have 1 mole of helium plus 1 mole of nitrogen gas. So we add those together, and our total pressure is 1 mole of helium plus 1 mole of nitrogen. Partial pressures can be used to calculate the amount of gas produced in a chemical reaction, and we'll get into that more later. All right, so here's a couple questions for you. You'll be answering these on Educate, and I'll have these come up for you in just a second. All right, the first question is, the average of kinetic energy of particles in a substance is measured by A, mass, B, density, C, temperature, or D, pressure. One mole of oxygen in a 5-liter container has the same partial pressure as 1 mole of hydrogen in the same container. This is a demonstration of what law? The law of conservation of mass, the law of definite proportions, the law of conservation of energy, or Dalton's law of partial pressures. Okay, go ahead and answer this on EduCanon as well, and I will, tomorrow in class, you'll be watching a video. We're continuing working on your vocabulary, and then you have some questions out of your book. Tomorrow night we'll continue on with 12.2.